welcome to True Projects. In this video, we are going to explain about a project titled Multitask Cascaded Convolutional Networks Based Intelligent Fraud Detection for Designing Automated Robots. Fraud detection holds the significant importance in agriculture applications like yield estimation, disease management, and quality sorting. Developing the robust fraud detection algorithm, however, is a challenge due to the unpredictable and the diverse condition of orchards, including the varying lighting background, occlusions, and orientation. The study highlights the analogy between fruit and phase detection tasks, underlying the effectiveness of cascaded convolutional network for the phase detection. It acknowledged directly adopting the CCN to fruit detection indicate to the distinct functionality required for each task. To address this, the research introduced an enhanced multitask cascaded convolutional network for intelligent fruit detection. Additionally, an improved image fusion-based augmentation method is proposed to counter the limitation of conventional fruit detection technique. This innovative approach aims to enhance the accuracy and adaptability of fruit detection system in the complex agriculture environment. Fruit detection has gained the immense popularity within the agriculture, finding the utility in the tasks like yield prediction, quality sorting, and the disease management. However, the intricacies of devising the robust detection algorithm stem from the complex and unpredictable conditions found in orchards, encompassing the challenges such as variable lighting. And it's highlighted that the direct application of CNN to food detection is unsuitable due to the distant tasks they cater to. In response, an advanced approach is proposed involving a multitask cascaded convolutional network tailored for intelligent food detection. Furthermore, an augmented technique rooted in the image fusion is introduced, aiming to rectify the shortcomings observed in the traditional fraud detection method. This novel strategy aims to bolster the precision and the versatility of the fraud detection system to integrate the setting of agricultural landscape. And these are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. This project began by importing the essential packages and libraries, establishing the foundation for creating the intelligent fraud detection system. And the next one is exploring the dataset. The dataset containing the images of fruits is explored to comprehend its content and characteristics, which serve as a basis for training and evaluation. And the next one is image processing. It undergoes the pre-processing procedures such as resizing, normalization, and the noise reduction to enhance the sustainability for the subsequent analysis. And the next one is loading the pre-trained model. Load pre-trained MTCNN model already trained on the large dataset is loaded. This model has learned the features that can be leveraged for accurate fraud detection. And the next step is data augmentation. To augment the dataset and introduce the variety techniques like rotation, flipping, and cropping are applied to create the additional training sample. And the next step is processing the data based on the YOLO v5 model. The data processing adheres to YOLO v5 model specification. This step involves formatting the data to align the model to the input requirements. And the next step is building the model. Here various models are built. The first one is YOLO v5. It is an advanced object detection model that employs a single neural network to simultaneously predict the object classes and the bounding boxes coordinate within the image. In this project, it is considered as a potential model for the fraud detection. It is known for its speed and accuracy in detecting the objects, which makes it suitable for any type of application. And the next one is YOLO V8. It's the family of the object detection model. It aims to improve upon the performance of the previous versions of the YOLO and typically include the advancement in the network architecture optimization technique and the feature extraction method. And the next one is MTCNN. A means of multitask cascaded convolutional network is specialized model designed for the task like face detection. It operates in cascaded manner where multiple stages are used to gradually refine the object detection, and this project it is considered for the fruit detection, indicating its potential adaptability behind its original purpose. Its cascaded architecture aids in detecting the complex pattern and the features which be the beneficial in identifying the various types of despite challenges by varying shape, size, and occlusions. And the next one is user gives the input as image. Here we build a Flask as a web interface where the user provides the input image containing the fruits for analysis and detection. And the next step is the given input pre-processed and with the trained model. The input image is pre-processed to match the model input requirements. The model then processes the image to detect the fruit object. And the next one is that they segmented each object and put the bounding box. The model identifies and segments the fruit objects within the image and assigns the bounding box to encapsulate the location. And the next one is the final outcome is displayed. The project culminates by presenting the result to the user. The outcome typically include of input image overlaid with bounding box around detected fruit object, enhancing the user understanding the detection process. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it, the sample folder containing of images within it, which is used for testing the performance of the model, and the static folder containing of the CSS images, fonts, assets folders within it, and the template folder containing of the home, index, notebook, sign-in, sign-up pages within it, and the YOLO V8 models containing of the algorithms training and the validation, and the test and train folders containing of the images that will be used for testing and the training the purpose of the model, and app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operation, such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the notebook is an IPYNB file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appear to be the database file that is used to store the user information. And for execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder path. By this it will change the current directory to the code folder path. And then click on the enter button. After this we need to write a command that is python space app.py. By using this command it will execute the Python script and perform the runtime check for any syntax errors or logical issues. And then click on enter button. After running this app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here it redirected to this page containing of the title and some information about it. And then click on the sign up button. Here it will redirect to the sign up page containing of some necessary details. To create an account, but my account is already created, that's why I'm using the sign in button. Here it redirects to the sign in page containing of the username and password, and here we need to enter those details of username and password and then click on the submit button. Here it redirected to this page containing of the choose file and upload button. Clicking on the choose file button, here it redirected to this folder containing of various images within it, and we need to select one image and then click on the open button and then click on the upload button. Here the result as of mango with the bounding box around it. In this way we can identify the fruits within the images by using the various deep learning model. And then click on the choose file button and select another image and then click on the open button and then click on the upload button. Here it's the result as of like this. And in conclusion, the proposed multitask cascaded convolutional network-based detector for the fruit detection performs well in the terms of accuracy and the time cost. More than thousands of images from the apples and orchards are labeled them to create a dataset. The proposed novel augmented method called the fusion augmentation, which can improve the final result, the detector can conveniently adapt to the other kind of fruit as well. The average time cost of the detector was less than 80 seconds per 100 images. This is very close to the real-time response.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.